Hi, my name is Emily Burko, and I'm a junior studying chemistry in the college. This summer, I worked with the Core Mode Lab researching nanoparticles as contrast agents for breast cancer imaging. So dual energy mammography seeks to serve the needs of women with dense breast tissue as it has increased sensitivity for this population. Currently, iodine-based contrast agents are used in DEM, but they have several drawbacks, such as their contraindication for use with renal insufficiency, their high dose requirement, and suboptimal contrast. So we've set out to develop an ultra-small molybdenum nanoparticle-based contrast agent that can address some of the issues with iodine-based agents, really to expand the number of women who can benefit from the diagnostic ability of DEM. So the synthesis of these particles is fairly simple and inexpensive. Aqueous solutions of the coating ligand and core components were combined and allowed to react for 10 minutes. The particles were then purified and filtered. I used several characterization methods to ensure that I had synthesized appropriately small molybdenum nanoparticles with a 2 MPa coating. And I found that the particles had an average size of 2.6 nanometers, which is well within the threshold for renal clearance. I then tested their stability in several different media by examining changes in their UV-Vis spectra of solutions after several time points had passed. We determined that the particles showed stability in water and in PBS, but results for the PBS-FBS solution were difficult to interpret as the media itself was not stable at room temperature. So actually testing the contrast of the particles was very exciting. I found that they produce strong DEM contrast as seen in this first image, and decent CT contrast, though the last figure shows that the performance of iodine as compared to molybdenum nanoparticles in CT applications was stronger. So to test the biocompatibility of the particles, I incubated them with HepG2 cells at a range of molybdenum concentrations and determined cell viability after 4 hours. In the future, I hope to perform more cell studies and ultimately test the particles' clearance and potential side effects in a mouse model. I would really like to thank everyone who's helped me from the Core Mode Lab, as I couldn't have done it without their support. In addition, I'm grateful to have received a Benjamin Franklin Scholar Summer Research Grant as financial support for this project.